Exercise 10.1, the first sum. It's a 6-mark question. So you have to find the probability distribution of the number of sixes in throwing 3 dice once. Okay, I'm going to throw 3 dice simultaneously. What is the probability of the number of sixes in throwing 3 dice once? So if x is going to be a random variable, okay, which is going to denote the number of sixes I'm going to get, right? So I can get either no sixes at all in all the 3 dice, or I can get 1 6 in one dice, and in the other 2 dice I might get some other number, or I can get 2 sixes, or in all the 3 dice I will get sixes only, right? So do you understand? I'll probably repeat. If I'm throwing 3 different dices at the same time simultaneously, what is the probability that I'm getting sixes in those 3 dices, right? I can get either no 6 at all, or 1 6, or 2 sixes, or 3 sixes. All the 3 dice that I throw shows sixes for me, right? That is what my random variable x is denoting, the number of sixes which I will get in throwing 3 dice at the same time. Okay, now what is the probability of getting 1 6 in a dice, right? So the probability of getting 1 6 can be written as 1 by 6. So in a dice you will have only 6 numbers. The probability of getting 6 out of that is 1 by 6. So the probability of not getting 1 6 is going to be failure of this, right? 5 by 6. 1 minus 1 by 6, which is 5 by 6. So I can write it as the probability of getting a 6 is 1 by 6, and the probability of not getting a 6, I'm denoting it as ns. Okay, now let's use these variables that we have here. So probability of x equal to 0, in the sense all my 3 dice are showing non sixes, right? So I'm having 3 throws, one throw for 3 dice here, and all the 3 dices are not showing sixes. So it becomes 5 by 6 into 5 by 6 into 5 by 6. So which is nothing but 5 into 5, 25 into 5 is 125, and 36 into 6 is going to be 216, right? Now let's go to the next. Where I'm going to get 1 6, right? So it can either be first dice can have 6, the next two can have not 6, or it can be like the first dice has not shown me a 6, but the second dice is showing me a 6, but the third guy is not showing me a 6, and the third could be first and second dice I'm not getting a 6, but in the third dice I'm getting a 6. Okay, so what is the probability of getting a 6? It is 1 by 6, into of not getting a 6 is 5 by 6, into 5 by 6. So the same thing happens 3 times. So I'm straight away going to multiply this by 3, right? So I get this cancelled. So 5 5s are 25. 25 divided by 12 6s are 72, right? Sorry, it's a mistake here, right? 6 6s are 36. Sorry, 6 6s are 36, and 36 into 2 is going to be, and I think it's better you don't cancel this 3 here, because it would be better if all the denominators were 2 and 6, because when you write the probability distribution function, if everything has the same denominator, you can add it and see it is equal to 1. Okay, so let's just not cancel this. 75 into 3 would be 25 into 3 would be 75 divided by 216. Now the third situation, right, where I'm getting two sixes. So it will be first 2 times I'm getting a 6, third time I'm not getting a 6. Then first dice shows me a 6, second does not show me a 6, third dice shows me a 6, and the first dice does not show me a 6, but the second and third dice show me a 6. So in this case also it would be showing a 6 is going to be 1 by 6 into 1 by 6 into 5 by 6, and that I'm going to do it 3 times, because for these this will also be the same, right? So you will typically get 15 divided by 216, and the last is when my random variable takes the value 3, which means I'm getting 6's in all my 3 dice, which means it is 1 by 6 into 1 by 6 into 1 by 6, which is nothing but 1 by 216. Now what are they asking us in the sum? They are asking us to write the probability distribution. So let's write the probability distribution for this. So which is going to be, my x takes the values 0, 1, 2 and 3, and when x is equal to 0, my probability is, what is the probability when x was 0? It was 125 by 216, and when x was 1, it was 75 by 216, and then it was 15 by 216, and here when x is equal to 3, it was 1 by 216. I would suggest, if you can do the sums along with me, you can pause it and you can pause the video and always go back and see whether you're doing it correctly. But it will be very effective if you can do the sums along with me. So this is basically the required distribution function. So this is why I said don't change the denominator. So since the denominator is the same, if you add 125 plus 75 plus 15 plus 1, you must get 216. Therefore, the sum of your probabilities is equal to 1, which is the basic rule of the probability distribution function, right? So if you write this, 6 marks is all yours.